Okay, so welcome everyone to the extended UNSD Brown Bag. My name is Alexander Loschke, and I will be moderating this webinar today with my colleagues Sean Lovell and Panya Yu. We are extremely happy to have our colleague Daniel Hopp from UN Trade and Development, which apparently is the new name of UNCTAD, with us, who will present on the topic free to play, developing your own open source retrieval augmented generation and fine-tuning large language model application. So the experience from UNCTAD. Large language models have exploded in popularity and attention over the past year or so. However, they can be of limited use when applied to specific domains or new developments that lie outside the training data they were built on. So Retrieval Augmented Generation, or RAG, and fine-tuning make large language models aware of and more useful for organizations' specific domains and work. So UNCTAD, through its Global Crisis Response Group, has developed a completely free to run and open source application to leverage these techniques. So this talk will provide a primer on large language models in general, RAG, fine-tuning, and we'll walk through the use cases and the implementation process. The applications for constituent libraries are available for installation and use on GitHub. So let me now quickly introduce Daniel. Daniel is a data scientist with the UN Global Crisis Response Group. Before joining the UN in 2020, he worked in the private sector as an analyst at a private equity fund, as the head of analytics at an e-commerce startup, and as the principal data scientist for Internet of Things startup. At the UN, he is trying to leverage his experience in data ecosystems, machine learning, and programming to drive innovation within the UN system. So, as I said before, so we will have a Q&A session at the end. If you want to ask questions during the presentation, please raise your hand. I will later on share the link to the UN Training Resources Group, where we will share the recording. And that's it. So I would hand over now to Daniel. Daniel, please go ahead.
Great, thank you. So let me share my screen and get the presentation up. There we go. Okay, so thanks for the introduction, Alex. Today I'm going to be talking for about 35 to 40 minutes, walking through the application and some background, giving a short demo, and then hopefully we'll have plenty of time at the end for discussion, questions, etc. So yeah, as Alex mentioned, this is going to be about open source LLM applications, and then a bit more specifically about RAG, or Retrieval Augmented Generation, and then also a little bit on fine-tuning. And those are two methods or two extensions of LLMs that can make them more relevant for your work. So I'll first do a quick background on LLMs in general, and then explain what RAG and fine-tuning are, how they work. Then I'll go through why that's useful and how we've been using it at UNCTAD, some of our use cases. Then I'll do a brief talk through of the actual libraries and applications that are developed to actually leverage that in the end and use it. And that's the part that's like open source. So anybody here, if they're interested, can go through and install those afterwards. Then I'll give a short demo, and then we'll move to the Q&A. So we'll start talking about LLMs. I assume that the vast majority of you, or many of you, have heard about LLMs over the past year and a half or so since ChatGPT came out. But I'll start at a very basic level just to make sure that everybody is on board with kind of the basics of what these are and what they can do. So in essence, LLMs are very large artificial neural networks, which are trained on large amounts of natural text data. So this can be from the internet. At this point, most of the large language models that you're going to see or interact with have pretty much been trained with almost everything that's publicly available on the internet, and they're now moving into private agreements with companies, data, and so on, because really the power of these models comes from the amount of information that you're able to feed them. So what they do in essence is they input and output. So as an input, they'll take natural language, and then as an output, they will also produce natural language. So what they're actually doing at the end of the day on a very basic level is essentially just predicting the next either word or series of words based on what has come before. So based on the context from which it's being asked its question. So what that does is produces outputs that very closely mirror or exactly mirror how natural language is constructed. So that's why, in large part, they've become so popular, because you don't need to know special, data structures or know particular things about modeling or how the data need to go in. You can just ask the question as you, in your natural language, would think of it, and you'll get an answer in that same format, which makes it much more accessible and flexible than more traditional machine learning models, et cetera, where you have to, have numerical data or in a certain format. Or be, a data scientist to work with the model inputs and outputs. You can anybody can just go in, type a question into the chatbot, and get an answer in natural language back. So what that means is that not only are the models able to respond to you in natural language, so they are aware and capable of creating answers in that format, they also have a very large knowledge base. So when their training data contains, the majority of the internet, they're aware of many different things. And that basically makes a lot of the draw appeal as well, because it's this kind of omniscient model that you can ask anything you want about any topic, more or less, that you want, and you will get back a response in natural language about that topic, particularly as you have formulated it. You don't have to rely on, reading through Google results or reading through Reddit posts or Quora, et cetera. It will just answer exactly what you have asked and not, what others have asked or similar to that. So that on paper sounds really great, and it is really great. And probably a lot of you have had experiences with ChatGPT or Bing or other closed-sourced offerings. So why would we even talk about, let's say, augmenting them? Like, what's the limitation with that? Why can't we just use that kind of straight as they already exist? And that's where RAG comes in. So in essence, one of the limitations of those foundational or vanilla LLM models is that they're only going to be aware of what they were trained on. So if you ask it a question, a vanilla model, because at this point in time, they're trying to incorporate agents and external information, et cetera. But if you take the vanilla ChatGPT or Llama 3, whatever model you're looking at, and if you ask it a question about an article or an occurrence, about something that happened after its training date, or about a niche domain or a specific domain that it wasn't trained on, you are likely to get either one of two responses. One being, sorry, I can't answer your question, I don't know about that. Or just as often, and perhaps more damaging, a hallucination, which is the agreed upon term for when the models produce answers that are not grounded in truth and may sound very convincing, but are not actually, grounded in facts. And so that obviously can be very dangerous, because they are so good at emulating human speech and seeming omniscient that you might take whatever they say at face value and as truth. I think there was a good example of that when a lawyer used it to kind of come up with case comparisons for his case, not realizing that it was just making them up. So it's very important that you're aware of that, because at the end of the day, what they're good at is predicting the next word in a series or the next sentence in a paragraph. And so what it produces is things that are very convincing. And if it's, a truth, like a fact that was contained in its training data, then it's very likely to reproduce that and thus reproduce a fact. But if you're now asking it about something new outside of the scope of its training data, it now may have a lower probability when it's predicting that next token, but it will still give you the next most likely thing to be there, which may or may not be something that is actually true, but it at least sounds true or is plausible. So one solution for kind of getting ahead of that problem is just, okay, why don't we just retrain the LLM every week or every day, however often we're interested in, and that way we know it's aware of all the latest information, and we'll have no problem with hallucinations because it will all the time be up to date with everything that's going on. So the problem with that, as you may have heard, is that it's very expensive and time and computationally expensive and time consuming. Basically, it costs hundreds of thousands, if not millions of dollars to retrain a foundational model from scratch, to do the pre-training again from scratch, and can take weeks, days, weeks, even months sometimes for the latest models. So that's obviously not going to be a feasible way for you to introduce new information to the model, especially at the level of an individual or a small organization using these models. So that's where retrieval augmented generation comes into play. And this is an approach that basically makes the LLM aware of new information, but via means that doesn't require you to retrain the model. So that's obviously much less expensive and much easier to implement. You might have experienced this. I think some things like doc search or document intelligence, sometimes ChatGPT will or Bing will let you upload a document, and this is an implementation of RAG, which I'll explain in the next 2 slides. So, oops, there we go. So what RAG does is it basically leverages the context window of the LLM. So the context window is basically the working memory of the model. So how much information it can kind of process at one time when it's answering your query or creating the predictions. It's very analogous to like a person's working memory. How much can I kind of recall from our conversation? If it's in the last 5 minutes, probably a lot. If it's 2 years ago, probably very little. And so there's something a little bit similar to that in the LLM, where it can consider a certain set amount of information, but if you ask it things that are even longer than that, it won't be able to properly process that. So what you can do is leverage that context window to provide new information alongside your query. So if we take, by way of example, a prompt like summarize the BBC article, if you just send that to a base LLM without RAG implemented, it'll do one of two things. First, it will either summarize a random BBC article that it was trained on. So obviously, as I said, they're trained on a lot of information from the internet. So for sure, there were tons of BBC articles in that training data. So basically what it'll do is it'll take that question, summarize the BBC article, and just take more or less at random one of those articles and summarize them. Or B, which is maybe more desirable, but equally as useless, is it'll say, I don't know what BBC article you're talking about. Can you elaborate? But if you were to ask the question, summarize the BBC article, the full text of which is this, and then you give it the full text, now it has grounding, it has context, it knows which BBC article you're talking about, and it will give you a proper summary of that article because it knows what you're talking about. You provided it alongside your query. And so if you think about that question and that query, there's no element of retraining the model. We didn't have to change the weights of the model in order for it to now be aware of that BBC article. We leverage the context window to say, this is the text of the article. It can process that all at once and give you the correct answer. So that at the crux is what RAG is doing. It's kind of putting new information alongside your query into the context window to basically ground the LLM. And what that'll do is basically cut down on hallucinations. It'll mean that it's not just answering from no context. It'll have a grounding of what it is you're actually talking about. So there are limitations to the context window. If LLMs had an infinitely large context window, what you could do is just take all of the new information you wanted it to be aware of and put it inside the context window. Basically say, I don't know, I have 500 reports on this topic. I literally just put all of them into the context window and say, answer this question. The answer is somewhere in these 500 of thousands of pages of documents. Find it and give it to me. And that would work if you had an extremely large context window. The problem, of course, is that the context window is not infinitely large. It is limited. It's growing all the time, but it's still not infinite. So if you think of something like ChatGPT's GPT-4, it has a context window of 32,000 tokens. A token is more or less a word. It can also be punctuation and parentheses and things like that. But it's more or less a word. So, that's a lot of context window, but it's not infinitely large. And if you look at open source ones like Llama 3 or Llama 2, then you're getting down to 8,000, 4,000 respectively context window, which is, a couple dozen or maybe, 5 to 10 pages, but it's still not, you can't dump everything that you want it to be aware of in there at once. So what RAG does is it basically tries to address this limitation of the context window by introducing an intermediary step between your query and the LLM. And the goal of that process is to basically be very parsimonious with the information that you're wanting to pass to the model, to the actual LLM itself. And how that works is via this concept of vector databases and vector retrieval, which is where the retrieval part comes in Retrieval Augmented Generation. So what you'll do is that you have this new kind of knowledge base, this new corpus of documents or web pages or whatever it is that you're interested in having the LLM be aware of. And you now do a pre-step of embedding and vectorizing those documents. So what that means is basically you transform the documents into a vectorized chunks, basically. So an embedding model, in simple terms, is basically taking the text and converting it to numerical vectors. So what the vectorization in the embedding model is doing is taking the semantic relationships between words or sentences or concepts and quantifying those and putting them into a vector in a kind of abstracted dimensional space, abstracted vector space. And why it does that is because now you have these words and sentences, etc., expressed as numbers instead of words. And with numbers in a vector space, you can calculate closeness and proximity. What does that mean a bit more concretely? It's if you take something like mountain and hill. These are two words that, in terms of the letters or the actual characters inside of them, have nothing really to do with each other. They're very different, but obviously they have a very close semantical relationship. So context, when you're talking about mountain, you'll often find hill. They're used in similar contexts, like the words around them will be similar. And that's exactly what the embedding model is picking up on. It's finding the numerical representation of these words. And so what you'll end up with is mountain and hills vectors will be very close together, even though the letters are not similar. So what that can do is let you have words grouped together by semantic similarity and not character similarity or stuff like that. So once we have taken all of our documents, we split them up into finite chunks. And that's basically the role of the chunk is to have discrete sections of text. So if I want to ask a question about climate change in one of the documents, the whole document may not be relevant to climate change, just one or two paragraphs. And so by splitting it up into chunks, I now make it discrete. And so I can retrieve just the chunks that are relevant to climate change instead of the whole document, where I might be wasting a lot of context window if I'm giving it 20 pages of irrelevant things to climate change just to get this one paragraph on climate change. So what chunking does is lets you have more discrete, smaller, relevant chunks to what you're saying, and it lets you use that context window much more efficiently, basically. So then how does this now fit into the LLM? What it'll do is that when I send my query, so what does this report say about climate change? What will happen is that it won't go directly to the LLM with that query. What it will do first is embed my question. So what does the report say about climate change? Put that into the same vector space that the document has been encoded into, and then look for vectors that are similar or close to my question. So if I've asked about climate change, it's going to now go through all the chunks of my documents. This can be thousands and thousands of them. Vector search in general is very fast and much more efficient than like standard text or keyword search. So it'll go through all of my vectors, see what's the most similar to my query, and then retrieve those 5, 10, whatever it may be, most relevant chunks to my question. So then I've now got these, 5 chunks of, let's say, a paragraph each. So I have now the 5 most relevant paragraphs from my documents to climate change. And it will now say to the LLM, answer this query. What does this report say about climate change, given this context? And then it will put those 5 paragraphs into the context. And then the LLM will answer your question. So what we've done is basically taken this very large, let's say it's a 500-page report, but it only has 2 paragraphs or 3 paragraphs about climate change in it. We've enabled the LLM to basically answer the question about that report without having to send the entire report in there, and just have given it the 5 most relevant sections to our question. And now it will answer it, and we've now efficiently used the context window, and we have an LLM that is able to basically respond based off of new information, because this vector database can be, you can download an article from that day. It's a very inexpensive operation. We'll actually do it later in the demo. So there's no kind of limitation to that. And so you can have an LLM that's aware of new information very cheaply. So that is what RAG is at its crux, and that's why you can make LLMs more aware of new information. But there's a second approach, which we've also implemented in the frameworks and in the libraries that you'll see later, which is fine-tuning. So RAG is great, but it's not perfect. So if you think about what I just described, it means that the LLM is not truly aware of all of the information in the new documents that I'm giving to the model. At the end of the day, I'm relying on the vector search to retrieve just the most relevant parts. And actually, the LLM won't be aware of anything else in that report other than those 5 paragraphs or whatever I retrieved. That might be fine if I've retrieved the 5 relevant chunks, but say that there were actually 30 relevant chunks, and that would be a much larger context window. It doesn't fit. Even though they may be relevant, it's still not going to be aware of them just because you have these limitations of context window, etc. So that can be a problem if you, say, have a very large corpus that you kind of want a little bit of input from a lot of different sections or a lot of different individual documents. The model is not going to be simultaneously aware of all of the information in those documents. And that's where fine-tuning comes into play. So basically, what fine-tuning does is it does actually change the underlying model. So with RAG, we didn't change the model at all. All we did is add a new step on top to pass relevant information alongside our query. Fine-tuning is actually changing the underlying LLM, but it's in a way that is a lot less expensive and a lot more, let's say, doable or accessible on a small scale. So what you're doing with fine-tuning is basically taking the underlying LLM, freezing the majority of its weights, say 90 or 95% or even more, and then you're only enabling the retraining of a very small subsample of the LLM. So what that does is obviously cuts down dramatically on the time and cost of retraining that model, because you're only retraining a small fraction of it, not the entire thing, but you are indeed still retraining it. So what people generally use this for, or why this is useful, is kind of two main benefits or things that it enables. One is knowledge injection, and then two is task augmentation. So for knowledge injection, that's kind of what we've been talking about with RAG. How do we make the model aware of new things, either a new domain or new in time events, etc. So fine-tuning can do that. You'll change the underlying model to now be aware of this event the same way that it was aware of an event 10 years ago, because that was in its pre-training data or foundational training data. For task augmentation, what that is basically changing the nature, more or less, of the model. So when you talk about a foundational LLM, which is the kind of base level of it, the original way that it's trained from scratch, generally speaking, what they're optimized for, or how they work, how they were trained, is text completion. So what it's actually being trained on at the end of the day is like millions and millions, maybe billions even, of observations of, this is the first half of a sentence. This is the second half of that sentence. Now I want you, given a new half of a sentence, to predict the second half of that sentence. And that's kind of the feedback loop that they're initially trained on. And that is giving it the information and the knowledge around, how to use structured language, how to use grammar, etc. So it's learning how to properly structure a sentence that makes syntactical sense, is grammatically correct, etc. And at the same time, what that's doing is introducing the information, the knowledge to the model. Where if I say, the neighboring country of France it's going to have, a lot of samples in its training data about France, just because there's a lot of information about it. So it'll know that if that's the first half of my sentence, the next part is probably going to be whatever, Italy, Spain, whatever it may be. So it simultaneously is getting information, because it's learning things about France, and then also grammar, basically, and structure. How should these things be said? Style, and that type of thing. But what you may notice with sentence and text completion is that it's not exactly, I think, what most people think of when they think about ChatGPT and these chatbots. And the key word there is the chat element. People don't interact with these things by saying, here's one half of a sentence, tell me what the next half of it is. They kind of want to ask questions. Like, I don't want to interact with ChatGPT by saying the neighboring country of France is, you answer me. I want to ask, what's the neighboring country of France? So with task augmentation, what you can do is basically have a small sample of kind of question response pairs that teach the model basically how to answer questions in this way. So basically expect questions, don't expect sentence completion. So that's what we mean by task augmentation. And so you can create a model that's much better at answering questions rather than completing paragraphs or texts. And that's often what you see if you look at models, or you get into Hugging Face and look into downloading models, etc. You'll often see the model itself. So you'll see Llama 3 70 billion, and then you'll see Llama 3 70 billion instruct, or Llama 3 70 billion chat. And what those are fine tunes of the foundational model, which have been fine-tuned to do question, answer, style, chat response. So I will show an example later of fine-tuning when we go to the demo part, but keep in mind that that's just a different way to make your model more relevant, which addresses some of the shortcomings of RAG, because the model is simultaneously aware of all of the information in the fine-tuning information set. Okay, so that will go into kind of the uses and why we're kind of interested in this at all. So I just have here a couple use cases. Yeah, a couple use cases just to kind of get your mind spinning. In my experience, I don't think this is the problem. I think people in general very quickly come up with how this can be helpful to them. But just to give a couple examples. I have a few listed here. So one that I've found quite useful is to basically take research papers on a topic that you're looking into, and then use it to synthesize that information into language that's appropriate for your level of knowledge on that topic. For instance, if you're starting out researching a new topic, you can have it, start with the technical information as in the RAG, like you uploaded these technical research papers, but then you can ask it to explain the concepts in simple language for a non-technical person to basically get you up to date on that. And then later on, you can change the register, ask it to explain it to you in more technical terms, etc. But it's super helpful for research and grounding your research in reputable data, not just relying on what happened to be in the training data of the vanilla model. Another element is with coding. So LLMs are super good at coding. But where RAG or fine-tuning might come in with that is if you are needing help with, or you use more obscure programming languages or libraries. I think this is often the case in NSOs, international organizations, where you might have very specific software for the type of work that you're doing, which doesn't have good coverage on the internet. And so the vanilla ChatGPT coder or whatever will not be super helpful with you on helping for that. But if you have the documentation for that, say they put out a PDF or a website where they have their documentation, you can use that in the RAG and have it be helpful for these more obscure programming tasks. You can synthesize reports from different agencies. This is the example I'll show later on of the fine-tuning. So you can basically fine-tune on the output of an organization and then basically use that to get that publication's perspective on new topics. So you can kind of combine fine-tuning plus RAG to get that type of output, which has some super interesting results. And then you can also incorporate LLM-generated responses into kind of back-end flows. So I think a lot of people think of this chat interface and ChatGPT, et cetera, where I'm just going to log in and chat with the LLM. But you can also incorporate these things into services. So for instance, one example we're talking about on UNCTAD is kind of pre-populating mission report fields. So this would be a field that you see as a user when you log in, and that field would have been pre-filled by a summary from an LLM without having someone actually have to do that at first. So it doesn't just have to be a chat interface. So that's all well and good, but how do we use it? Like, how do I, okay, that's interesting. How do I leverage it? So there's basically 4 libraries that enable this. And I'll talk in the next couple slides about other things, because of course you don't have to use these things. They're just here as resources if you're interested. You can do all of this with commercial software, and I'll talk about the pros and cons of that in one of the next slides. But if you are interested in doing something that's completely free, you have the option to look at these 4 libraries. So the first one is for document processing. So if you think about all those things I said about vectorization, chunking, et cetera, you need to have the data in kind of raw text format, because that's how the embedding model will expect it. So this first library handles that whole element, converting HTML websites, PDFs, Word documents, CSV files, converting all of that into the actual text that the embedding models and ultimately the LLM will expect. The next library is for the actual LLM and RAG itself. So that library is modular, so you can use different LLMs. If you find a fine tune or you make a fine tune that's particularly relevant for you, or if you want to use a bigger or more powerful model, that's all modular, and you can just choose what model you want underpinning your system. Then the next library is for fine-tuning. So the fine-tuning can be completely outside of the flow. You don't need to use fine-tuning. That would just create the fine-tuned model that you can then use as the underlying LLM for the application. And then finally, there's the front end. So that is the thing that actually you're going to interact with. And that's just what you need if you want this chat interface. If you're just interested in backend processes, you don't need it. You can just make an API out of the LLM responses and deliver them that way, however else you want. It's just an option for the front end. So all of these libraries are Dockerized and can be run on any PC. Obviously, it's much better if you have a GPU. You'll kind of see the performance in the demo. It's very fast and as fast as you would expect, faster than you can read. So it's generally speaking useful. Apple Silicon Max, so anything with an M1 or higher chip, also works very well. And important to note is that you can run them on really any computer, so even one without a GPU or CPU only, but that's probably going to be too slow for kind of live chat as you're used to doing it. If you're okay with that limitation, you can use it like that. Or perhaps if you want to incorporate into backend things where you batch run things overnight and you don't care how long it takes because you have 12 hours to do it, then you can kind of run these things on a CPU as well. And now we get into that very hot question of, okay, that's cool that it's open source and free, but that takes effort for me to implement and host and serve, etc. Why don't I just use ChatGPT? Why don't I just use Gemini? Why don't I just use whatever, Bing? So just kind of these four main topics in that regard. I'm happy to talk about them further. I'll just give a quick overview here. But the first one is obviously cost. So those services either cost money or will potentially cost money in the future. I think right now we're in a state where there's a lot of subsidizing of generative AI in order to basically create the market and generate interest. Where you try to create the product free, create temptation, get people to use it, and then later on you introduce a cost once people have become hooked on it or dependent on it for the workflows, etc. So that's one element. It's just the cost. If we think about, for instance, if we want to give Copilot Pro to everyone at UNCTAD, it's 500 people, $30 a month. We're talking about like $15,000 a month. That's obviously a huge expense and a very difficult one to justify. And a lot of these providers have per user pricing rather than institutional or shared pricing. And then the other element of the cost question, which I've actually found to be almost a bigger driver than just the actual cost itself, is just this question of getting new cost streams approved. Just going through that process of getting buy-in and getting somebody to approve that cost stream can be very, burdensome at NSOs or at the UN. So if you're able to bypass that and kind of get experimenting without needing to incur costs, that can really get you moving a lot faster than waiting for those processes to move. The next element is that of data privacy and security. So obviously, when you are querying ChatGPT or Bing or whatever, all that information is going to the servers of those companies. That includes if you are using RAG, then that means every document that you're uploading is going to be going directly to the servers of these companies. And that's where you're going to have to weigh in your organizational setting how acceptable that is. But it's obviously a big element that people are talking about in terms of privacy and security. You can have data leaks. You can have the companies can change their stance on how they use the information. Just because they don't use it for advertising now doesn't mean that they will in the future. They can and have used the things that people send to them to train new models. So this is kind of a way of exposing your information or data to a much broader audience than perhaps you kind of conceptualized when you were using the tool just because it was helpful to you. So when you have a completely kind of in-house open source local system, you can control where things are stored and whether or not they are stored. So you can set it up so that the queries are not saved anywhere, but in the RAM, so it's cleared out every time the machine is reset, so that you don't have these privacy issues of people's personal queries being stored somewhere. It just is not stored, and you can control that. The next element is that of customization and control. So obviously the big providers have different, let's say, target audiences than you as an organization may be. They want to appeal to a broader consumer base, and they are interested in introducing features that are useful for that much larger pool. And if you have niche or more specific ways of using it, you either have to wait till perhaps it gets implemented in what they're doing, or just not have access to that feature. Whereas if you kind of have your own tool that you can tweak in any way that you want, that works for your team of 5 people, you can do that. You don't have to just hope that one day it gets implemented by a big company. And then the last one, which I think is perhaps one of the more important elements of this, is that of fostering institutional knowledge and capacity. So a lot of people are being exposed to things like LLMs and generative AI, and it can be a very, I think, black box and daunting kind of relationship where it's this new technology, you don't really understand it. The companies are not necessarily interested in having you understand it, because what they want is just buy the product. Yes, it's magic, it's really cool, just use it, don't worry about it. And when you actually are building it and working with it yourself as an organization, you build up a lot of deeper understanding of how these systems work. And I think that's incredibly important for understanding their limitations and the correct and most useful way, basically, to apply them. So that's, even if we don't end up using this application in the end, we still have institutional knowledge that is independent of the actual application we use in the end. I think I'm going a little longer than I expected, but the next step that we're doing now at UNCTAD is, now that we've developed the application, is that of onboarding, rollout, and training. And that kind of plays into that last point of what I just said, where because we have a very, very deep understanding of the system, how it works, what it is and is not doing, limitations, etc., that means we're much more effectively able to kind of inform and train our colleagues and future users on how to correctly use it. And that's obviously a really important element when you're talking about actually using in a work setting the outputs of generative AI. So we can have a quick look at the application. I'll do this in 5 minutes, and then we can move to the question and answer. So this is basically this is the chat interface. Obviously, there's a lot under the hood that you can use apart from the chat interface, but this is what you'll see if you load it up. So basically what you're seeing is the standard, ask your question, but you also have these elements to do with RAG, uploading your own documents, different ways to get information into the system. You can do a URL, you can do Google search, so kind of bypassing. I could do a Google search and then download the files and upload them again, but this is just incorporated directly into the application. This is a bit of what I was talking about with customization. So within our team, we wanted a way to get research papers and things quickly into the application without having an intermediate step of downloading files. So I could just build this in based on our requirements, where you can use Google News to summarize the latest news. What I've found it quite useful for is getting, so if I have questions about a new topic, I will just go in here, put in my query, so say vector database, and then restrict it to a reputable source like arXiv, process it, and then ask questions on research papers without my first having to go through and download them. You have a lot of hyperparameters. So which LLM do you want to use? Right now it's on Llama 3, 8 billion instruct, but if you wanted to, you could put it in here at your fine tune. You could put in Llama 2, whatever you want. You have the corpus that you want to query against when you're talking about RAG. And then you have the advanced parameters. I won't spend too much time on that, but basically anything that you would want to do to kind of tweak your model and its outputs, you have access to there. And so let me very quickly show an example of fine-tuning, because I think that it's a good way to show what fine-tuning can do. So the background for this is basically I fine-tuned the LLM on the Trade and Development Report, which is in a publication of UNCTAD. And then I, for the RAG, just put in a CNN article, just the top article that day. And I basically asked the question, so this is the vanilla model, what would the Trade and Development Report say about this article, which happened to be about detention centers in Gaza? And I don't expect you to read this right now, but basically what it said is, I don't know what it would say. Here's some general information about the TDR. I know that it's a report published by UNCTAD. I know generally what it's about, but I don't really know how to answer your question. Whereas if we compare that to the fine-tune model, so what I did for this fine-tune was took the last 10 issues of the TDR, put it in as the fine-tuning training data set, and then asked the same question. And again, I don't expect you to read it word for word, but in general, what's going on here is that we have a model that basically is much more kind of aware of the Trade and Development Report and its positions, because it's kind of specialized on that report. So what this model is doing compared to the base model is saying, okay, I know what the TDR is, I know what it does. It doesn't say anything in particular about this article or what it's talking about, but I know kind of what the TDR says, I know what it's about, I know its standpoints, so I will answer your question from that context, and in the end gives you a reasonable and much more relevant response, highlighting that, you know, the situation in Gaza is a part of a broader pattern of political instability that affects many developing countries. And that's the type of language that you can find in the TDR. So what you've ended up with now is you're now basically able to kind of talk to the TDR and get information on new inputs from the perspective of that publication. Of course, I could have done it on like all of UNCTAD's flagships and then kind of had an UNCTAD model, be able to ask what would UNCTAD think about this, or I could do the same thing for a different organization and compare what that organization would say about a new topic compared to UNCTAD and so on. So that's just something to give you a little more concrete idea of what fine-tuning kind of does. So that's all I had to show. Now I would open it up for questions and discussion.
Yeah, thanks, Daniel. Really fascinating. I have already a couple of ideas in my head how we could use this. And that's the purpose, of course, of this talk in the brown bags. So let me open up for questions. Just as a reminder, we won't record the Q&A session. I mean, we will record it, but we won't share it, so we will cut it out. So please, if you have questions, raise your hand.